Good day everyone, my name is Faith Faz from C1A, your speaker for the day in Discrete Mathematics. So right now we're going to talk about propositional logic. First, what is logic? Logic is the basis of all mathematical reasoning, a study of reasoning based upon statements or proposition. Next one, what is proposition? Proposition are the meanings of statements. Is a declarative statement which is either true or false.
Here example of proposition. First is today's raining day. Watermelon is one of summer's best treats and tells that this is true and this is either true or false, because either true that today is raining day or false today is not raining day. Next one, it's either the statement can declare true or false. It's an interrogative sentence or a question, and an imperative sentence showing a command or request. This is the examples. This one is simple and compound propositions. The meaning of simple propositions are independent and give us information about a single fact. The example of this is Philippines is made up of 7,641 islands. So we have here compound proposition consists of two propositions joined by connectives such as and or but and others. Example: always wear your mask, using and bring your own alcohol. Next topic is constructing propositions. Compound proposition constructed using logical connectives or logical operators. The basic rules needed to construct a truth table and look at some examples of truth table to determine if a compound statement is true or false. True or false, true denoted by T, false denoted by F. Also, truth table is statement represented by a letter or a variables. An example of that. And next one, so we have here connectives is a well-formed formula and connects the propositional variables. We have 5 connectives. The first one, so this is the negation of P. This is the sign that we can use, this which means not P. And in here we have the truth table. The truth value of not P is opposite of the true value of P, which is P will be not P. So TF, and under of that is F and T. Take note, P is the hypothesis and Q is the conclusion. The example of negation, the first one statement and the opposite statement using not. Next one, we have here conjunction for any two propositions. P using this sign, Q, which means P and Q. And here we have the truth table of conjunction, which means if conjunction P and Q is true when both P and Q are true, otherwise is false. Next one, conjunction, the example of conjunction using and. Next one is disjunction. For any two propositions also, P using this sign, Q using V, and which means P or Q. This is the truth table of disjunction, which means that if disjunction P and Q is true, when either P and Q is true, otherwise is false. Next, this is the example of disjunction using connective or. So we have here implication for any two proposition also. P using the arrow to the right Q, which means if P then Q. This is the truth table of implication, which means that implication is false when P is true and Q is also false, otherwise is it true. It's true. Next, the example of implication using if then. We have biconditional for any two propositions, P and two arrows, Q, which means if and only if. This is the truth table of biconditional. which means implication is true when P and Q have same truth values and is false otherwise. Next, exclusive or P and the sign Q different, which means that different than, and this is the truth table, which means it will be true when either P or Q is true and false when are true both are false. Next, propositional formalization. Let us learn to symbolize natural language into propositional logic. So we will take for granted that every letter we use represents a sentence. Propositional logic. First one, define letters with the sentences they stand for. Example, let P, eating ice cream on sunny day. Let Q, watermelon is better for summer. Second one, in symbolizing, we should try to break each natural language sentence into an atomical sentence. Example, my sister and I always bring alcohol. Could be defined, let F, my sister always bring alcohol. Let E, I always bring alcohol. For the third one, to express negation in a negative sentence, it will be better expressed as a positive sentence. Examples, you don't have to follow the protocols. Let P, you have to follow the protocols.